Alright, today we will be working with Unit 1, Lesson 5 and 6, and I thought we would go ahead and start with a magic square. If you notice, this magic square is a 4 by 4, so it becomes a little bit more difficult. Instead of dealing with 9 numbers, you're now dealing with a total of 4 times 4, 16 numbers. So you have 1 through 16. You can see that several numbers have been placed. Go ahead in your black notebook and write down Unit 1, Lesson 5 and 6. And then if you would make this magic square, we will get started. So what I'm going to do here is I'm actually going to tell you the magic number for the magic square, because just by increasing one column and one row, it becomes extremely difficult. So your magic square number is 34. So every row, every column, and every diagonal has to equal to 34. So go ahead and write that down and then start plugging in the numbers. 6 plus 13 plus 12 plus what number would equal 34? Alright, 13 and 12 is 25. 25 and 6 is 31. So in this square right here, you would need 3, because 31 plus 3 equals 34. Here you have 10, 5 would be 15, and 18. And what number plus 18 equals 34? Hopefully you have 16. 5 plus 12 is 17. 17 plus 15 is 32. So what number would go there? And so on, until you have the puzzle complete. All said and done, you should have answers of 4, 11, 14, 5, 6, 13, 12, 3, 9, 2, 7, 16, 15, 18, 1, and 10. Let's move on. Here you have a kin, 4 by 4. Go ahead and draw this into your notebook as well and solve. Remember, when you're dealing with kins, look for the obvious. Again, we're dealing with a 4 by 4, so the largest numbers that you can use are 1 through 4. But right here is one cage of 4. So now this column and this row cannot use 4. Alright, so finish this before you return to school tomorrow, and we will talk about it in class, so make sure that you remind me about your kin. Let's move on to the lesson. Draw a line in your black notebook, write Unit 1, Lesson 5, and we are dealing with unit rates, products, and rate tables, and that's on page 15. So everything I highlighted, please write down in your notebook. And then let's get started. It says, is a constant rate reasonable? For each rate situation, fill in the rate information in the rate table. Label the columns in the table. Discuss what you assume in order for the situation to be a rate situation in the real world. Possible discussion points and assumptions are given. Number 1, every day of this week, Joanne made 3 of her free throws. Not likely unless she stopped each time she makes 3. So what would that look like? So below, write number 1, and it says that she will be making 3 free throws per day. Alright, your rate table should look like this. Underneath units, you should have the day, and the product would be the free throws. So in 1 day, she makes 3. In 2 days, she makes 6. In 3 days, she makes 9. And 4, she makes 12. And then on the right, you have a plus 3, plus 3, plus 3. Now, again, with this rate being reasonable, again, it would not likely unless she would stop each time she makes 3. Number 2, Ephraim makes 8 sketches on each page of his drawing book. So what would that look like? Number 2, make your rate table. Alright, so you'd have 8 sketches per page. Your unit would be pages, your product would be the sketches. So in 1 unit, which is 1 page, you'd have 8. In 2 pages, you'd have 16. In 3, you'd have 24. And in 4, you'd have 32. And again, off to the side, you have plus 8, plus 8, plus 8. So again, is this constant rate reasonable? And it would be yes, because he divided the pages into 8 sections. So each page would have 8 sketches. Alright, so if you look on this page, and I'd like you to draw these, you have equal groups and different ways to represent equal groups. Up at the top, you have unit rate 6, 6, 6, 6, 6, and you have 5 of them, so times 5 would be a total of $30 total cost. And over on the right, you have the product of 30. Group, you have a 6, and then you have that times 5 stacks, again for a total of 30. And then down below, you have representing 24. You could have 4 rows, and you could have 6 plants per row, and 6 times 4 is 24. Or you could have 4 rows, 6 plants, and then you have the 24 plants represented in the middle. Just different ways to represent equal groups. So the top 2 is one way, and the bottom 2 is a different way. All right, make sure that you finish copying these equal groups in your notebook. And then if you need to pause it, go ahead. And then let's look at problem number 4 on page 15. It says, Eusebio planted 7 tomato vines in each yard he takes care of. So again, we're trying to figure out if this constant rate is reasonable. So make your table, unit product, your it'd be 7 vines per yard, 7 tomato vines in each yard. So go ahead and fill that out, complete the table. All right, so you have yards and vines. The unit is yards, product is vines. 1 unit, 7 vines, 2, 14, 3, 21, 4, 28. You're increasing by 7 each time. Now, it says, is this a reasonable rate? And you have to be thinking about the size of the yard. So size of the yard, not likely, because it could change. All right, turn with me to page 16. Still working on rate tables. Number 5 and number 8 are the 2 that we're going to do on page 16. Is it a rate table? Decide whether each table is a rate table and then explain your answer why or why not. So number 5, you have the rate table started. 1, 9, 2, 18, 3, 27, 4, 36, 5, 45. So go ahead and make that rate table. And then let's jump over to number 8. 1, 3, 2, 5, 3, 8, 4, 10, 5, 13. Again, you are to say if it's a rate table and explain why or why not. All right, so number 5 should look like this. You should have rate 1, product 9, and it's increasing by 9 each time, so it would be yes, and it would be a constant increase. Now let's take a look at number 8. On number 8, you'd have unit and product. 1, 3, 2, 5, 3, 8, 4, 10, 5, 13. This would not be a rate table, so you'd say no. Again, it's because of not a constant increase. All right, let's take a look at what will be your homework in class, or your schoolwork in class. 1.5 homework side. For each rate situation, find the unit rate and write it using per. Make a rate table that includes the given information as the first row in the table. Continue making a scrambled rate table. So number 1, we have Aunt Susie's rectangular garden has 40 carrot plants in the first 8 rows. So what would that look like completing the scrambled rate table? Well, we know that there are eight rows in the first 8 rows, and that there are 40 carrot plants in all. So on the line, your unit would be rows, and your product would be plants. And we know that there are 8 rows, and with 8 rows you have 40 plants. Now the unit rate, the unit is scrambled here, so now you have, if you had 1 row, how many plants would you have? If you have 25 plants, how many rows would that be? If you had 15 plants, how many rows would that be? We're trying to figure out the unit rate. So 8 goes into 40 how many times? 5. So if there was 1 row, you would have 5. So you just figured out that for every 5 plants, for 1 row, per row. So that's where the per part. So 25 would be 5, and 15 would be 3 rows. Okay, so that's what you'll do in class. All 6 of them are exactly the same. And you have your remembering page as well. Let's take a look at, let me just pause. Page 17, which is the start of Unit 1, Lesson 6. So draw a line in your notebook and write Unit 1, Lesson 6, Unit Pricing, page 17. All right, here we go. Scroll down a little bit. It says Unit Pricing Situations. These 3 rate tables show the prices of 3 different kinds of granola. Each has a different unit price. Fill in the missing values in each table. So we have 3 tables with different unit prices. Over on the right, we have unit price, x-axis, y-axis, unit rate triangle, and coordinate plane. Go ahead and copy these definitions down. First one is unit price, the unit rate associated with a price or cost. Example, $4 per pound. So copy that down. The unit price, $4 per pound. The x-axis is the horizontal number line in the coordinate plane, and the y-axis is the vertical number line in the coordinate plane. And then unit rate triangle. You do not have to copy this definition down, but I am going to ask that you write the example. But it says when a rate situation is graphed in the coordinate plane, and that's what we're going to be doing, the unit rate triangle is a right triangle with base equal to 1 and height equal to the unit rate. The third side of the triangle is part of the line representing the rate situation. All right, so let's just look at the example because that's going to make more sense. So here we have an example. In the unit rate triangles in this graph, the base is 1 and the height is 3. The unit rate is 3. So what I would like you to sketch in your notebook is this information I'm going to highlight in yellow. So here's your unit rate triangle. You have your labels, dollars and pounds. Here's your x-axis. Here's your y-axis. 0, 5, and 10 pounds. And then in dollars you have 0, $5, $10, and 15. So what it's showing here is 1 pound, $3. So there's your 1 and 3, your x and your y-axis. And then it shows 2 pounds, 6, 3 pounds, 9, 4 pounds, 12, 5 pounds, 15. And then you can see what the definition was saying. You have 1, 3, and then you have 1, 3, then you have 1, 3, and so on. So that's a unit rate table, or unit rate triangle, and you can see that the shape, the reason it gets its name is the shape of a triangle. And this last definition you don't have to copy down, but coordinate plane, a plane together with a pair of perpendicular number lines that intersect at 0 on each number line. The perpendicular number lines are called axes, and that's where we get the y and the x-axis. And then the example down below here, it says the coordinate plane is divided into 4 quadrants by the x and y-axis. Below is the first quadrant of the coordinate plane. So if you look at, you have the first quadrant, x and y, and I just remember x comes first in the alphabet, so when you are plotting coordinates, x comes first. So I always make a little table like this. I have an x column, y column, and 3, 2. So x is 3, y is 2. So this is my x-axis, this is my y-axis, and I would plot that point at 3 up 2. So right here, that would be called, where it intersects would be 3, 2. All right, so back to page 17, we have unit pricing situations with those granola bars. Let's just scroll way up here. Okay, so number of pounds 1, cost is 3. Number of pounds 2, cost would be what? Number of pounds 3, cost would be what? Number of pounds would equal to cost of $12. Go ahead and draw number of 1, that rate table in your notebook. And then let's take a closer look at number 1. All right, so 1 pound, $3, 2 pounds, $6, and so on. 4 pounds, 12, 5 pounds would be $15, 6 would be 18, and 7 would be 21. So you notice that it's increasing by 3 each time. Now look at table number 2. Here, and go ahead and draw the rate table. You have number of pounds, cost in dollars. Now this one's a little different here, and I want to point out right here, because 1, 6, 2, 3, so far we're going up in pounds consecutively. 1, 2, 3. But here you have this squiggly line here, and then you have 10. What they're doing there is they're saying that it's jumping from this number to 10 instead of representing everything in between. So let's take a look at what that would look like completed. So go ahead and again make that rate table. All right, so problem number 2, table 2, 1, 6, number of pounds 1, cost 6, number of pounds 2, cost 12, and so on. 4, 24, it should be a 5. Oops. But now here, instead of going to 6, it goes to 10. So if you figure out the rate increase, or the of 1 through 5, then 10, and if you think about it, 5, 30, 10 would be double that, 60, and then 100, 600. All right, let's take a look at this problem on page 17. It says, what's the error? Dear math students, I made this graph to show the first 3 rows from table 1. When I tried to draw the unit rate triangle, and that's what we're working on. I realized that I did something wrong. Can you help me figure out what mistake I made? Your friend, the puzzled penguin. So over on the right, he was going to make a unit rate triangle. And here you have the x-axis, y-axis, dollars, pounds, 0, 5, 10, 0, 5, 10. So it says, write a response to puzzled penguin, then draw the correct graph in the coordinate plane above. So we would have to draw it over above here. So it looks like he has 3, 1, 6, 2, 9, 3, but something he did wrong. Hopefully you realize that what happened was that he actually reversed the order of the coordinates. It should not be, it should be 1, 3, not 3, 1. So as you're graphing this, you should be graphing it 1, 3. So here it'd be 1, and then be up 3, 1, 2, 3. Then 2, 6, not 6, 2. Here's 2, 1, 2, 3, 4, 5, and 6. So making the corrections, you would have your unit rate triangle right here. Here's one triangle, there's 2, and I just have to continue with the other coordinates. All right, if you would, turn to page 18, Unit 1, Lesson 6 still, Unit Pricing. And again, we have ordered pairs, x-coordinate, y-coordinate. And you have relate table, equation, and graph. So let's just take a look at this. I think the answers are in front of you now, but I just want to talk about this. A number of pounds, 1 costs 3, 2, 6, 3, 9, 4, 12. Nothing unusual. Now over here is where it gets a little tricky. Number of pounds times the unit rate equals the cost in dollars. So you have pounds times R equals cost. Variable P, variable R, variable C. 1 to the 3 is your unit rate, would be 3. 2 this times 6, 3 would equal 6 then. 3 times 3 would equal 9. So all it's doing is it's adding that side over here. Number of pounds, 1 times 3 is 3. So it circles, the unit rate is circled. Imagine the unit rate written on the vertical row to be multiplied by the number in the left column to get the number in the right column. 2 times 3, 3 times 3, 4 times 3. Okay? Alright, homework then in school would look like this. For each table, find the unit rate, unit price, then complete the table. So let's look at number 1. At Best Buy Fruits, 9 boxes of strawberries cost $36. What is the unit price for 1 box? So you can see that they have 9 $36. Number of boxes, 9, cost $36. But that's not the unit rate. What's the unit price for 1 box? Well, 9 goes into 36 4 times. So 1 times 4 would be your unit rate. Okay? Unit price for 1 box would be 4. And you just need to complete the rest of it. Okay? Down below here, number 3, A, B, C, D. It says for exercise 1 and 2, what assumption did you have to make for these to be constant rate situations? So it's asking once you complete 1 and 2, what assumption, what did you have to assume was going to happen? Okay, so we'll talk about that in class. And then the remembering page looks like this, more factor puzzles. Again, you're focusing on the 12 and the 8. What factor do they have in common? And we'll work on that as well in class. And then down below, same thing, we have to write the equation and then give the answer. That concludes Unit 1, Lesson 5 and 6, and we will work on it more in class tomorrow.